All right, under the heading of this is something you should probably look at tonight. Can Rolle's theorem be applied to the graph at the right? Why or why not? There are three conditions for Rolle's theorem. You should know them. Condition number one is that f of one endpoint has to equal f of the other endpoint. In this case, that's true. One endpoint is -3, maps to 1. Also, the other endpoint, 1, also maps to the y value of 1. So that piece is true. The other two conditions, that it is continuous on that interval and it is differentiable on that interval. Those are the other two conditions for Rolle's theorem to be applied. So you'll need to know what is continuous and what is differentiable and when is it not, as opposed to a graph. Let's look at number two. Number two flat says Rolle's theorem can be applied on this one. We know that this is just a simple parabola, so this is definitely continuous and differentiable. If you plug in -1 and you plug in 3, you should get the same y value, so those should go there. And then you're going to have to know what to do with it from there. Obviously, find the c value here guaranteed by Rolle's theorem, such that f prime of c is 0. All right, let's talk about average rate of change on an interval. You'll need to know, what does average rate of change mean as opposed to instantaneous rate of change. You'll need to find the average rate of change on this interval from 0 to 2. From number 3 up above, you're going to have to find the c value in the interval from 0 to 2 such that f prime of c is equal to that secant slope. Okay, this is the mean value theorem. Basically, it says somewhere on the curve, the average rate of change and the instantaneous rate of change are going to be the same somewhere in this interval. So find a c in this interval such that those two values are the same. Last but not least, draw a visual representation of what's going on from number 3 and number 4. And that's your preview for tomorrow.